Hello everyone. So today I'm gonna tell you something about ocean currents. So today's topic is ocean currents. In my previous video, I've explained tides and waves, and in this video we are gonna talk about third type of oceanic movement, that is ocean currents. So let's get started. What are ocean currents? Ocean currents are uh, the tides and waves that we talked about. They are more visible to us, like in the real time, and also they take place at a very small scale when we compare it with the ocean currents. So, what are ocean currents? Ocean currents are continuous, predictable, directional movement of seawater. It is a movement in ocean or seawater that is continuous, that is happening on like non-stop, and we know that which direction it's gonna flow. So it's predictable as well. It is following a pattern since years, and it is following that pattern, and it will follow that pattern. It is a massive movement in the ocean water. There are various reasons behind the movement of this ocean currents. Okay. The movement in ocean water takes place in two direction. If this is our ocean, then it will move like this. It is horizontally, or it can move upward. The water from the below can go up. That is vertical movement. The horizontal movement is known as current. So, continuous, predictable, directional, horizontal movement of seawater is known as ocean current. Okay. What does the vertical movement of ocean water called? It is known as wellings. That is upwellings. When the water goes up, it is known as upwelling. And when the water from top goes down, it is known as downwelling. As simple as that. This ocean current, this horizontal movement of water, has a very important or various impact on human life as they influence the climate, because these ocean currents have a significant impact on the climate and various other conditions which impact the life of humans directly. Okay. The reason behind ocean currents are two type of forces: primary forces and secondary forces. In the primary forces, there are majorly four forces that are responsible. First is solar heating. When the water gets heat up due to sunlight, it tends to expand, and this creates a gradient effect. How does it create a gradient effect? Let me explain. Imagine this is the earth and here's the sun, and when the heat waves come from sun towards the earth, the part that gets most of the heat or the solar energy is the equator, and here the water just tends to expand more because gets heat up, and the particles from there they expand, and the water level here rises, and it is at a higher level than the water at the polar or the that is present in other region than the equator. And this water, since the water here is at the higher level than than the other regions, it creates a gradient effect. And the water moves from a higher level to the lower level. The next force responsible for this is winds. The winds over the ocean are very strong and they tend to take water along with them in the direction of their movement, leading to the horizontal movement of ocean water. This causes the movement of water at the surface level of the ocean. The next force is the gravity. The gravitational pull of Earth is not constant everywhere, it differs, and it tends to pull objects towards the center of the Earth. So, in the regions where the gravitational pull is high, the water tends to move downward, and the regions where the gravitational pull is not very strong, the water does not get attracted towards the center of the earth that much. Thus, there's a gradient or there's a slope being created. This is the high gravity area. This is the low gravity area. This the water sinks here, and here it is not that much attracted towards the center. This the water from this region tends to fill in the sink in this region, and the movement of water takes place. And this is another form of current. Next is the Coriolis force. What exactly Coriolis force is, that I'll explain in a later video. I'll make a separate video for it. But as of now, you just understand because of this force, the water in the northern hemisphere moves towards the right, and it makes the ocean water in the southern hemisphere to move towards the left. What exactly it is, I'll make a separate video for it. Okay. So coming to secondary forces, first one is the density. We know that there are various factors which affects the density of water. It can be salinity of the water, temperature of the water. So high salinity leads to high density. High temperature, that is the warmer the water, less denser it would be. Okay. In the case of salinity, it's directly proportional. In case of temperature, it's inversely proportional. So the dense water tends to sink while the relatively lighter water tends to rise. Denser sink, lighter rises. This is the reason why it leads to a vertical movement of water. So the denser water present in an ocean, if the salinity is high towards at the top of the ocean, the water is denser here, so it will fall down. And since the water present at the bottom is not so dense, it will rise up. Similarly, the water at the top, which is more cold, will be denser and it will sink. And water at the bottom, it will be warmer, will tend to rise. And it leads to vertical movement of water. Okay. Next secondary force responsible for formation of current is the temperature of water. At the pole, the water is cold. At the equator, the water is warm. So since the cold water is denser, it tends to sink, and the warm water is lighter, it tends to rise. And the water from the equator moves towards the poles, and the water from the poles move towards the equator. And this leads to again formation of current. So the water traveling from warm area, cold area is known as warm current. So it is known by the name of origin, not the destination. And from cold to warm area, it is known as cold current. Okay. So coming up to the, I hope this is clear. Now moving on to the, now we'll talk about the classification of ocean current. The classification here we're gonna do on the basis of the like depth. There are two types of currents. Surface current, which takes place most, which is like movement of ocean water majorly on the surface level. As I told you that the movement of wind causes the water at the surface level of ocean to move, creating currents. So surface water, so wind is a reason for surface ocean current. The impact of such current is that it transfers the and heat transfer. It wind blows from the tropics towards the poles. So it carries warm water from the tropics towards the poles. So it helps in increasing the temperature at the pole and decreasing the temperature at the tropics. So it helps in heat transfer. Next is deep ocean current, which is the movement of ocean water at a deeper level. It can be, as I told you, surface level ocean current is caused because of wind. The deep water ocean current can be due to the density. When difference in density leads to movement of water vertically and at a deeper level. So that is a reason for deep ocean current. It maintains the salinity and the temperature. It transfers the salinity from a high concentration area to a low concentration area. And also the temperature distribution, it tends to affect that as well. Okay.